All right, we are on our first video lesson for our notes. This is 9.01 for Algebra 2. So in a couple of the classes, we already talked about a little intro into this, talking about some of these different vocab words. So the measure of dispersion is whether the data is spread out or clustered. I gave you a set of data right here in this box, so you are going to want to use your calculator for this one. And you want to find each of the following, rounding to the nearest tenth when necessary. So the first thing we're going to do is put this into our calculator. And again, as I told you in class, I don't really have a great way of showing that, but I can write out your steps as you guys type it in. So I want you to hit Stat, and then go to Edit. And then you're going to type in all of these numbers in for L1. And one of the nice things that the calculator does is it'll arrange it for you to find the median. So you don't have to rearrange it in from least to greatest. You can type it in exactly as you see it. Once you type that in, you're going to hit Stat, Calc, and then number 1, which is 1 var stats. And that's going to give you a whole bunch of information. So if you haven't typed that in already, hit pause and go ahead and type that in. All right, so on your, and when you do this, any of these problems, you want to make sure you always write out those calc steps if you're using them. So for the range, we're doing max minus min. So that one's pretty easy to do from your data if you just look at the top part. But if you look on your calculator screen, it'll list the max and the min. You might have to scroll down. So just hit the down arrow so that you find max, which is 11, and then your min, which is 1. 11 minus 1 gives us 10, would be our range. Next, it asks you to find the mean. So the mean is the first one there, and it's important to know the symbol to represent that. So X bar is another way we say mean, and that is 5.06 repeating. And this direction said to round to the nearest tenth when necessary, so we're going to round that to 5.1. The standard deviation we talked about is how spread out your data is. So if the standard deviation is really small, it means that your data is really close together, surrounding a certain point. If the standard deviation is big, it means your data is really spread out, not as consistent. So the population is, we're going to assume that's what we're using unless stated otherwise, unless they're going to tell you that you're using the sample. So the population means you're using every piece of data that's given to you, surveying every person in your group, where a sample would just be taking a smaller group of people to represent the whole. And then we're going to round that to the nearest tenth. The sample is S sub X, and that's also right in your calculator. And if you have trouble finding any of these, let me know. You can send me a text or email me, and I can even show you like a screenshot of my calculator, or you can send me a screenshot of yours to figure that out. Before I continue, I didn't mention here what the mean is, and the mean for especially in the one class we didn't talk about it. That is the same thing as an average. And to find the average, like you guys do to find your grades in class, you'd add up all of the numbers and divide by how many you have. So that's how we calculate your grades normally. And variance is another way to represent the spread of the data. It's just your variance, or it's just your standard deviation squared. So you can find this if you go to vars on your calculator and then number 5. You can do it that way. The population is just taking this number up here and squaring it. So that'll give you that actual number, or you can just type in that number straight in and then square it. and that gives you 7.928 repeating, rounded to the nearest tenth, would be about 7.9. The sample squared, so now you're going to take this number right here and square that, which will give us 8.495238095, which is approximately 8.5. So again, your variance is just this squared, which we have written right here. So in summary, the measures of dispersion describe numerically how spread out or clustered your data is. The smaller the value, it means the closer the data is together, the more consistent it is. The most unreliable is the range, and that's because it's based on only two values in the set. And one of those values is your max, and the other is your min. So again, in some of the classes, we talked about what an outlier is. And oftentimes the outlier is going to be usually the maximum or the minimum. So if you're finding the range and you're using that outlier to find it, then that's not going to really truly represent what your data, the majority of your data looks like. Now, the median is going to be the most reliable because that one will not be affected by any outliers. So some of you in class had said the mean, and we talked about that while that is better than the range, it wouldn't be the most reliable because, again, it's going to be affected by that outlier. So if you're adding up all your numbers and then dividing by how many you have, that outlier, if it's a really large number, then it's going to pull that average or your mean up higher than the majority of your data. Next, we've got 17 students in Mr. Kanjemi's AP Calc class that took a quiz with the following results in ascending order. So these are listed already from smallest to greatest. Use your calculator to determine the mean, median, and quartiles. I don't know what all these little lines are here. For the set of data, and then we're going to do a box and whisker plot review from algebra. So let's write our calculator steps down. We've got stat, edit, and then you're going to type in all of your scores for L1. Then we're going to do stat, calc, one var stats. When it asks you for what list you want, you're just going to make sure it says L1 since that's what we typed them in for. We don't have a frequency list here because we're just typing each one individually. So I want to talk about first how to do this in the calculator, and then we'll talk a little bit too using the data, how we can figure this out without the calculator. So the first part asked us for the mean, which is our average or X bar. So that gives us 83.47058824. Stop that. Yeah. And the median, it asks for next. The median is also known as the second quartile. Is going to be 84. Quartile 1, again, just listed right in your calculator screen, is 73.5. Quartile 3 is 94. And your min and your max will list here too. You guys probably called it the 5-number summary when you did it in algebra. And the max is 100. So we can clearly tell from the data that our min is 56. Our max is 100 because it's listed in order. Now to find the median, remember you guys remembered kind of crossing off each one until you get to the middle. And for here, my pens wasn't working there, but so that brings us to the middle right here, 84. So that's our median. When you find your first quartile, what you're doing is you're finding the median of the lower half. So looking at this half of the data, I'm going to use my finger. Actually, I can change colors here. So use my fingers to count in or cross them off ourselves. So we're kind of between two numbers right here, 72 and 75 for your first quartile. So when that happens, you just want to take the average of those two. So we would do 72 plus 75 and then divide that by 2, giving us 73.5, which is good because that matches up with our quartile down here from the calculator. And then quartile 3 is the median of the upper half of the data. So again, we're going to kind of cross off until we get to the middle. And the middle, again, is two numbers. So right between there is going to be quartile 3. So we average those together, 93 and 95. So that would give us 94. And that also checks with our calculator. So that's how you would do it without your calculator. Now, to actually graph the box and whisker plot, we need to set up a scale on this number line. So I need to get from 56 all the way to 100. So maybe I count by fives here. So 50, 55, 60, 65, 70, 75, 80, 90, 95, 100. And then how I do it is I mark usually right above. Some people mark right on the number line. I don't care which you have learned to do it. It's fine with me. But we're going to start by marking our minimum, which was 56. So a little bit past that, and I'm going to label it as 56, our minimum. And then I'm going to label my maximum at 100. And then I do 3 large lines for Q1, Q2, and Q3. So quartile 1 is 73.5. So this is really just an estimate. Then the median was 84. And the quartile 3 was 94. So a little bit before 95. And then box those 3 big lines up and draw your little lines, your whiskers over to the min and the max. So with a box and whisker plot, remember it's broken up so that there's 25% of the data between each quartile. So think quartile. So you've got 25% between your min and your Q1. You have 25% between Q1 and your median. 25% of your data between your median and quartile 3, and then 25% between quartile 4 and your maximum. So there are different places on the number line, but there's 25% of your data between each of those. Letter B says, what's the interquartile range of this data set? So let's answer that question first. So the interquartile range is also called the mid-spread or the middle 50. So it's taking a range which is not a great representation of our data, and we're making it a little bit more accurate. So instead of taking the max minus the min, we go in further. So to try to avoid some of those outliers, it gives us a more stable statistic. So you want to take your quartile 3, so we sometimes call this IQR, would take quartile 3 minus quartile 1. So instead of doing max minus min, we go in a quarter more on each side. So quartile 3 was 94, quartile 1 is 73.5, so our interquartile range would be 20.5. That is the first question. It says, in theory, what percent of the data should lie between the first and third quartiles? So in theory, between quartile 1 and quartile 3, we said that there was 25% here, 25% here. So altogether, that should give us 50% of the data. So this should always contain 50%. Should be between quartile 1 and quartile 3. Is this true? Is that true for this particular data set? Well, to figure that out, we need to figure out how many pieces of data are between quartile 1 and quartile 3. So I'm going to go back to the list right here. So I'm looking at quartile 1 is right here, and quartile 3 is right here. So I want to count how many pieces of data I have between those two numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 pieces of data out of a total of 17. It said there were 17 students, or you can count them, or on your calculator, N should be 17. We said 17 students. So 9 out of 17, you can do that right in your calculator and change it to a percent, and that's about 53%, which it's not quite 50%, but it's very close. And the reason that happens is because it's a very small set of data, so it's not going to end up being exact. The more data you have, the more exact that it will end up being. Letter C. What's the population standard deviation for this data set to the nearest tenth? How do you interpret the standard deviation? So we want to find in our calculator, which you should already have all this data in there, this lowercase sigma. It's a Greek letter. Looks like this. Sub x. That represents the population instead of the s sub x. We want the sigma sub x, and in your calculator it should say 12.000576669. Rounded to the nearest tenth is approximately 12.0. So what does that mean? It means that on average, any given data point will lie 12.0 units away from the mean. So the standard deviation tells you how far each point is from the mean, which was your X bar. So if it's smaller, then there's less variation, there's less spread of the data. Letter D, what percent of the scores were within one standard deviation of the mean? So this is a type of question that sometimes comes up on the regions. Round your answer to the nearest percent and show your work. So what we're going to do is we already found what one standard deviation is right here. So we want to take that and we want to take the mean, and we want to subtract that one standard deviation from it. So we're taking 83 which is our mean, 47058824, and subtracting one standard deviation from that. And we can type that right into our calculator, and it gives us 71.47001155. Then I want to take the mean and I'm going to add one standard deviation to it. So I'm taking my 83.47058824 again, but this time I'm going to add the 12.000576669. Type that into our calculator, gives us 95.47116. Okay, so we want to figure out what percent of the scores were within one standard deviation of the mean. So this is one standard deviation right here that we added and we subtracted. So we need to be between, actually, let's take a look at the number line before we decide those exact numbers. So 71.47 is between 71 and 72 on a number line. 95.4 is between 95 and 96 because it's a little bigger than 95. So to graph 71.4, it would be somewhere here, let's say. And to graph 95.4, less than half, would be here. So I want to be between these two values. Now we only have integers listed in our data, so we want to figure out which two numbers we're actually looking between. So since 71.4 would round to 71, you might be thinking 71, except if we look here, since we've gone above 71, we're not actually including that 71. The first integer that we actually include within one standard deviation is 72. And then We never actually include 96 either. So for this top one, you're always going to be rounding down for the higher number. And for the lower number, you're always going to be rounding up, even if that doesn't mean that it's following the rounding rules, because we want to make sure that we're within one standard deviation. As soon as we go beyond that gray line, we're no longer within one standard deviation. We're a little bit more than one standard deviation from the mean. So you really have to make sure you either draw this number line every time, or just remember that the bottom number you're going to round up and the top number you're going to round down. So we need to be between 72 and 95. So to find out, so now we're going to count how many data points are between there. So go up to your data again. And we're going to count if we're above, so we have to be above 72. Got a lot of colors on here. Let me just going to erase, maybe. There we go. Some of it at least. So I'm looking to find if we're above 7, we're between 72. So in this case, we're going to include 72 because 72 is within one standard deviation of the mean. So I've got 72, 72, and I want to stop once I get to 95, and I can include 95. So I'm going to count up how many I had. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 pieces of data are between 72 and 95. This asks what percent of the scores are within one standard deviation. So 12 of the scores are within one standard deviation, but we have 17 of the scores. So in your calculator, do 12 over 17, multiply it by 100 to find your percentage. And so this says to round to the nearest percent. So 70.58 would give us approximately 71% of the data is within one standard deviation. All right. So if you're feeling okay about that, then I'd like you to give the last question a try on your own. So if you could pause it, try it on your own, and then come back and check it with what I have. All right, so hopefully you've paused it and you've done this problem already. So you should, first of all, have your calculator steps written out. So you've got your stat edit. L1 is going to be this first one, L2, your frequency scores. So a little bit different on this one just because I haven't given you the frequency on any of the other ones. And we want to do number 1, which is one var stat. So when it asks for your list, that should be L1. And this time when it asks for the frequency list, we do want to put L2 in there. If you have an older calculator, so you don't have an 84 plus, then it won't ask you for that frequency list. You just have to use the commas and include it yourself. So if when you did it on your own, you got 77, then that tells me you didn't include the frequency list. So your mean should be 75. So that's if you included this part right here, the frequency list was L2. For the standard deviation, again, it's the population standard deviation I'm asking for with that sigma. It should be 7.88. I did not say to round, so you should write out that entire decimal there. The variance, we're going to take that number you just wrote down, and you're going to square it to get 62.25. And letter D asks what interval represents the range of scores within one standard deviation of the mean. So this is that last problem we just did, part D. So to figure this out, we need to find the mean, which we already have, and that's 75. and then we're going to subtract 1 standard deviation. So that's what we found in part B. And then we're also going to take the mean and we're going to add 1 standard deviation to it. Just type those right into your calculator. And then we want to figure out what integers we need to be between. So I'm going to draw that number line again just to figure this out. So 67.1, that's going to be between 67 and 68. 82.8 is going to be between 82 and 83. Let me change colors. So 67.1 is going to be right after 67. And 82.8 is going to be kind of close to 83. And so in between here, these 2 blue brackets is 1 standard deviation of the mean. So the first integer that I actually hit is going to be between 68 and then the last integer I hit is 82. So that would be the interval of scores that could be within 1 standard deviation. So then letter C says how many scores fall within this range. So you're going to look up at your table and figure out how many are between 68 and 82. So 92 is not, 87 is not, 82 is, so I'm going to include that. 77 is, 72 is, and 67 is too low because we only want to go to 68. So right here in the table. Now be really careful because what a lot of students do is they just say, oh, well, there's 3 scores there. But really we have 6 82s, we have 9 77s, and we have 10 72s. So these are the numbers we want to add up. So we're going to add up our 6, 9, and 10. So altogether, there are 25 scores within that range of values. And then lastly, what percent of the scores fall within this range? So you're going to take how many scores you had within the range and divide that by your total. So we have 25 scores out of a total of, and then in your calculator, you can find this would be your n value. Or if you didn't do that, you could just add up your entire frequency list. Either way, that should give you 40. So that's 0.625. Multiply that by 100 or move your decimal over twice, which gives you 62.5% of the scores. All right, and that is it for 9.01. Again, if you have any questions, please let me know. And I'll post your homework, which I think for tonight is going to be, I'm going to give you guys an assignment from your green book, a review assignment in there. All right, have a good day.